So hello guys, welcome to another video, and for this video I will be making another summary for the chapter 5 or the Ethernet. Let's get started. Ethernet operation, LLC and max-sub layers. Ethernet, one of the most widely used LAN technologies, operates in the data link layer and the physical layer, family of networking technologies that are defined in the IEEE 802.2 and 802.3 standards. Support data bandwidth of 10, 100, 1000, 10,000, 40,000, and 100,000 Mbps or 100 gigabits per second. Ethernet standard define layer 2 protocols and layer 1 technologies to separate sub-layers in the sub-data link layer to operate logical link control, LLC, and the max sub-layers. So this Ethernet, the most widely used LAN technology, and it is mainly our source of connection in the modern times. And as we encounter this as we connect some of the cables to access the internet and apply the connection to many support devices that our connection can handle. Continuation, LLC handles communication between upper and lower layers, takes the network protocol data and adds control information to help deliver the packet to destination. So the LLC, or the logical link control, it is responsible for taking the protocol data and adding some of the information in helping to delivering the packet from the source to the destination. For the MAC, constitutes the lower sublayer of the data link layer implemented by hardware, typically in the computer NIC. The primary responsibilities: data encapsulation and media access control. And for the Mac, we use this for the data encapsulation and media access control. So for the data encapsulation, its responsibility is to encapsulate every data to be sent from the source to the destination, and also for the control of the media access in upon sending and receiving from the two devices. Ethernet encapsulations. Early versions of Ethernet were slow at 10 MBs. Now operate at 10 gigabytes per second and faster. Ethernet frame structure adds headers and trailers around the layer 3 PDU that encapsulate the message being sent. Ethernet 2 is the Ethernet frame format used in TCP and IP networks. So shown here is the comparison between the IEEE 802.3 and the Ethernet 2. For the IEEE 802.3, we have the preamble, or the having 7 bytes. Start of the frame delivery, we have 1 byte. Destination address have 6 bytes. Source address the same. The destination address are 6 bytes. For the length, we have 2 bytes, and for 802.2 header and data, we have 46 to 1500 bytes. For the frame check sequence, we have 4. For the Ethernet 2, we have for the preamble, we have 8. So it has more bytes than the one in the IEEE 802.3. For the destination address, we have 6 bytes, which is bigger than the um. Okay. So they have different categories for destination address, same as the destination address here. Here at the IEEE 802.3 for the source address, we have 6, so they have the same as the 802.3. And for the type, we have 2. And for the data, we have the same as the header data for the 802.2, which is 46 to 1500 bytes. For the frame sequence, we have the same, or we have 4. Unicast MAC address. So this MAC, this is this unicast is the sending of a frame to its main destination address. For the broadcast, we have the sending of the frame to the destination, and by sending it and to search for the destination, then to find the main destination. So the frame must be sent to all the hosts. For the multicast, the frames are just sent to a destination host group, but excluding those other other devices that is not part of the sending. MAC and IP. MAC address. This IP address does not change, similar to the name of a person, known as physical address because physically assigned to the host NIC. IP address similar to the address of a person based on where the host is actually located, known as logical address because assigned to each host by a network administrator. Both the physical MAC and the logical IP addresses are required for a computer to communicate, just like both the name and address of a person are required to send the letter. So these two addresses, they are part of the addressing on the devices, and of course they need to meet some of the requirements before being used. Introduction to ARP. ARP purpose sending node needs a way to find the MAC address of the destination for a given internet link. The ARP protocol provides two basic functions for solving IPv4 addresses to MAC addresses, maintaining a table of mappings. So for the ARP, it is mainly used for searching for the MAC addresses, and of course finding the correct pathway in sending some frames to the destination also. Duplex settings have duplex. So as I have said, the half duplex um RT is the sending sending and receive or the sending of the of or receiving of the devices cannot be made at the same time. So in the image we can see that the switch is sending something to the server from the hub. So just go straight in. So if the server wants also to reply to the switch, then it will just after the switch logs in with this server, and then the server can can then send kind of a setback for full duplex. The devices can send and receive at the same time. Types of layer 3 interfaces: we have switch virtual interface, or the logic interface of a switch associated with a virtual local area network. So for this switch virtual interface, it is the one that the interface that we are configuring when the switch is involved. And for the routed part, physical port on layer 3 switch we configure to act as a router port. Configure routed ports by putting the interface in layer 3 mode with no switch port interface configuration command. Layer 3 Ethernet interchannel logical interface and system device associated with a bundle of routed ports. For summary, Ethernet is the most widely used LAN technology used today. Ethernet standards define both the layer 2 protocols and the layer 1 technologies. The Ethernet frame structure adds headers and trailers around the layer 2 video to encapsulate the message being sent. So this frame structure is used for the encapsulation of the message to be sent from the source to the destination. And as an implementation of the IEEE 802.2/3 standards, the Ethernet frame provides MAC addressing and error checking. Replacing house switches in the local network has reduced the probability of frame collisions in half-duplex links. The layer 2 addressing provided by Ethernet supports unicast, multicast, and broadcast communications. So this 3 in the layer 2 addressing is provided by the Ethernet, and it supports the three types of communication: the unicast, multicast, and the broadcast. Ethernet uses the address resolution protocol to determine the MAC addresses of destination and map them against the known network layer addresses. Each node on an IP network has both a MAC address and an IP address. The ARP protocol resolves IPv4 addresses to MAC addresses and maintains the table of mappings. A layer 2 switch builds a MAC access table that it uses to make forwarding decisions. Layer 3 switches are also capable of performing layer 3 routing functions, reducing the need for dedicated routers in the LAN. Layer 3 switches have specialized switching hardware so they can typically rotate as quickly as they can. And that's it for my chapter 5 summary, and I hope you learned from this video, and thank you for watching and goodbye.